Here's my latest project. I'm building up a small solar farm here. I've got a couple of 100-watt solar panels wired in parallel in the backyard. Here's my dog, by the way. And this is the interior electronics. Basically what it does is it takes the power from the solar panels and sends it to an inverter, a pure sine wave inverter down here. So let's talk about the components real quick. This is an EP-Ever 20 amp MPPT charge controller. MPPT stands for multi-power point tracking. It's a very efficient way to deliver juice to the battery, and I believe it's a 3-stage charger, and very nice, and not that expensive as well too. One of the reasons it's not all that expensive is because it doesn't have a display. You have to buy a display separately. This is the MT50, and it will indicate your volts and amps and things like that. It even has a nice little smiley face on it. Back to the EP-Ever, I would put my solar panels here. I connect them to these two, the plus and the minus. This is the plus and the minus to the battery here. This is 10 gauge wiring that's required for electrical code. Put anything less than that in there and you could overheat or have a small fire or something like that. That red wire ties into a 25 amp fuse on the fuse block. That's a 20 amp controller, and multiply that by 1.25 for various reasons, and you end up with 25 amps. So a 25 amp fuse here is adequate for the protection that I need. The black wire goes to the negative side of the fuse block, and then that's the negative lead that goes down to the battery, which is not hooked up yet, and the dog toys are down there too. The positive lead also goes down to the battery, which also isn't hooked up. Right here I've added a USB charge controller, or you plug your USB outlets in there, and then this is a cigarette lighter port right here, 12 volt power port, and they run up to here. The red wire on the left is wired to the 5 amp fuse, and the red wire in the middle there is wired to a 10 amp fuse, which your cigarette lighters are all 10 amp circuits. And then the two black wires here are the negative for that. Now ultimately the positive and the negative on the fuse block also tie in to a pure sine wave inverter, and an inverter turns DC voltage, like we're producing from our solar panels, into AC voltage. So I can plug AC devices into this here and create power. Now I'm going to put down here, I'll add a battery, and I'm going to put a lithium ion phosphate battery from a company called Battleborn. Very expensive battery, but also very efficient. Will deliver power slowly and for a long time. And I'm going to have a nice little system here with 200 watts of panels. I won't be able to power a whole lot, but I should be able to run a TV for quite a number of hours, maybe a little fan. I'll be able to power my 12 volt refrigerator, my portable refrigerator, from the cigarette lighter socket on here. Lights, no problem. I should be able to hook up some of my shortwave receivers to this thing because I don't use them all the time. But it's a neat little project. It did cost a few bucks, especially the battery, which is very expensive. And hopefully I'll have